Hi everyone, thank you for all the awesome feedback. I was just trying to be nerdy and talk about healthy stuff, but you like it, so I'll keep talking about it. While I've got our cool little stick figures out, I'm going to keep diving into these. In the last video, we were looking at how healthy fats can become bad fats in the event that you heat them. Uh, Today, I want to talk about what happens when we eat these fats. So, in essence, we consume the fats and they get into our circulatory system and bind to these triacylglycerols, which is just the fancy way of saying you've got this backbone and the fats will attach to that backbone. And usually there's three of them. And that's, if you've ever done blood work, it's a marker of how many of these fats are being transported through your circulatory system. So if you're in a fasted state or you're in a keto diet, you typically have higher triacylglycerides. Um, Ultimately, those fats want to end up inside of your cells. And when they're there, they've got two primary fates. One, they become energy, which helps power your body, all the physical movement, the digestion, everything else that happens. Or they can be used for building blocks, building material. For energy, we go through a process called beta oxidation, which is just a fancy way of saying we take two of these carbons at a time and break them off. And by breaking off these carbons, in essence, we're using the energy of breaking that bond to reform another bond called ATP, adenosine triphosphate. So you've got an adenosine and then three of these phosphate oxygen groups. We've got our phosphates here, and then it's surrounded by oxygen. Oxygen wants two bonds to be happy. These other oxygens only have one bond, but the way the structure ends up working out, the electrons can kind of flow like metal. It's conductive, it allows electrons to flow. So this compound has some stability to it. In essence, we break that bond, and then that bond breaking allows us to form other bonds. A protein will have ATP bound at the bottom and will grab onto compound A and grab onto compound B. And then as that bond breaks, it changes the shape of the protein and puts compound A and B in a perfect orientation to do chemistry, and you have a bond forming. Or you can cause it to have a bond breaking. So in essence, our body can use fats to break the bonds of the fats to generate more ATP. We break and reform more of this ATP every single day, more than our body weight. So this is the primary precursor for energy within the cell. So in essence, that's how our body takes fats and then turns it into energy.